Let's start. So first, let's use the standard library to get the qualitative data, categorical variable. So there's a standard library called mass, which is available within the R itself, and you can just write library mass, and you will have that data set being loaded for you in this particular session. Name of the data is painters. Let's have a quick glance of the painters data. So what this data is about is it has taken some set of famous painters in the world like Leonardo da Vinci also, and they have tried to measure these painters on these four variables: composition, drawing, color, and expression, and then which school they belong to. So they have created some school which is virtual school and ABCDE. So this is the data set field, and everybody can, you don't have to download data from anywhere, you just have to go write library mass. It's a standard library, comes as the standard installation, and you have to write library mass and you will have that in place. So if you need any help in terms of what this data is about and how should I interpret this data, this everything is there with this. You just have to type help painters and you will have the data available with you. Okay, so this is what the data that we have. So let's quickly see that what's the school. So this is a factor variable, and it has a different factors like A, B, C, D, E, F, G, H. So we are just I'm just making you familiar with the data before we move on to frequency distribution, relative frequency, cumulative frequency, and central tendency and different things. But we need to be thorough with what the data is and how do we move ahead with the data. So painters is the data that we are going to use for all the category related analysis now. So frequency distribution of the data variable is a summary of the data occurrence in the collection of non-overlapping categories. So this data we already have. Let's quickly create a variable called school. So we have a variable called school. Now we want to create another variable which will hold the frequency, and frequency, to get the frequency table is the function that we have to use. Correct. So now I have school dot frequency. It has a frequency stored in it. Let me see it. Okay. So with different schools of thoughts with the painter database, this is the frequency looks like. Let's have a better view of this table. Let's make it like, yeah. Okay. So this is how it looks like, the frequency distribution. What is the relative frequency is the overall percentage, how much percentage that category belongs to in vis-a-vis with the overall data. So this is the relationship between this is the formula of relative frequency. That relative frequency is frequencies divided by the overall size, the sample size. So let's calculate the frequency first and then divide the frequency with total number of rows, so total number of painters, and then that will give me a relative frequency. Yeah, and let me see this value. Yeah, so this is the relative frequency. Okay, let's plot a bar for this. Let's do a bar plot for this categories. So this is my frequency. Okay, I can see a bar chart. So bar plot is the function which plots a bar chart for you. It needs a variable called school dot frequency. That variable needs to hold the frequency for different categories. So how school dot frequency looks like is this. If you feed this to a bar plot function, then you will have a bar plot like this. Okay, so this bar looks very plain. If you want to like color it, we have created a different vector called colors, and we will feed that vector. So bar plot in a function, we have given only one variable earlier, one input parameter, but it can take color as call is equal to whatever is your metric, just give it and it will plot a colorful bar. So these are the standard keywords. You can explore more about the keywords whatever you want, and you can just feed in here and you will have a colorful box plot, bar plot here. Okay, how to do the pie chart? A standard function pie school.freq, and I have a pie chart of those observations. Similarly, we can also play color thing with the pie chart. We just have to select this, put it here, and then it will do a colorful pie chart. Cool. So we have a colorful pie chart now. Okay. So what are different characteristics? Let's go with the mean. So okay. So the task here is I would like to calculate a mean for the category C, where school is C. So what is the syntax is? What it will do is it will, whenever the school variable where we have stored all the school names ABCD, wherever it is C, it will give you a true, otherwise it will take a false. So let's see what is C underscore school captures. Right, so it's a false true combination again. So wherever it is C, it's true, otherwise it's a false. So they have created a data set. From above the data set, it's like a child data set, it's a subset slicing of data. And C underscore painters is a sub data set which has been created. And now I would like to see the composition scores mean for all the people who are in C. So I'll just press this. Okay, and I have a mean. So all the people who belong to C school, and their average of their composition is this. So mean is the formula that can be used for calculation of average. Or there's a suitable, there's a function called tapply that we have learned in the last lecture also. So what it does is it sequentially applies the formula, and then we will have mean from this formula also.